Simplify the following expressions. Your answer should only have positive exponents. But that's okay, we're pretty good at dealing with negative exponents at this point. So in the first one, A, I've got x squared times y cubed times 7 times x cubed times y to the 6th. So the only number that I have, right, the coefficient is 7. So I'll just write that in the front, 7. And I have factors of x and I have factors of y. The number of x factors I have 2 of them here and 3 of them there. So that's a total of x to the 5th power. X times x times x times x. In terms of factors of y, you can see there's 3 factors of y and another 6 factors of y. So that's a total of 9 factors of y. So the answer to A is 7x to the 5th, y to the 9th. For B, you can see we've got the quantity 3x to the negative 2nd power. So the only tool that we have for dealing with negative exponents is we've been neutralizing them with, for example, 3x raised to the 2nd power. Now I have to be careful because I'm multiplying this expression times something, and the only thing I can multiply it by and not change its value is 1. So I'm going to place a 3x to the 2nd power in the denominator as well, and that'll take care of not changing this. So if you look at it, when I multiply 3x to the negative 2nd power times 3x to the 2nd power, that equals 3x to the 0 power, right? They have the exact same bases, so negative 2 plus positive 2 is 0, and anything to the 0 power is 1. So those things that I've highlighted in blue end up just being the number 1 in the numerator. What's left in the numerator is 27 x to the 4th, y to the 2nd. And then down on my denominator, if you look, I've got 3x squared. This means I have 2 factors of 3x. So I've got 3x times 3x, which is 9x squared. So I'll write that 9x squared up here, 9x squared. Now if we look at this, this can be simplified. The 27 is 3 times 9, so if I want I could write it, I'm just going to do this. 27 divided by 9 is 3, right? So there's a 3 left over in the numerator. I've got x to the 4th over x squared. When I simplify that, x to the 4th over x squared, that gives me just plain old x to the 2nd power, right? That's x times x times x times x in the numerator, divided by x times x. There's just 2 factors of x left over in the numerator. And then finally, I've got I'm sorry, finally I've got, I don't know what's happening here. Finally I've got a y squared left over in the numerator, so I'll just copy that down. So if you look at what we're left with here, we end up with an answer of 3x squared y squared. So I'd probably write it like this, 3x squared y squared. And for the final problem, I'm going to go ahead and choose to neutralize this negative exponent first in my first step. So I'm going to multiply this by y squared over y squared. Again, this is equivalent to multiplying by 1, so I'm not changing the value. And the reason why I selected y squared is because I can see y to the negative 2nd power times y to the 2nd power is y to the 0 power, or 1. So I'm left with a 3x squared in my numerator. My denominator would contain 6 x to the 1st power and y to the 5th power. So we can simplify this a bit. 3 divided by 6 is 1 half. In other words, there ends up being a factor of 2 left over in the denominator. And if I look at my x squared, you can see that I've got my x factors rather. There's 2 factors of x in the numerator, that's an x times another x, and there's 1 in the denominator, so that ends up being just 1x left over in the numerator. So I've got an x up here, And then the final thing is, you can see there's still 5 factors of y that are left in my denominator. So my answer to part C is x over 2y to the 5th power.